Recall from our study of the mean that the mean is sensitive to outliers or extreme values. Let's also note that the linear regression model uses the means of the variables in its calculation. The linear regression model has this form y hat equals a plus bx, where a is calculated by the mean of the y values minus b times the mean of the x values. So we have means here. And then b is calculated by r times the standard deviation of the y's by standard deviation of the x's. And r is calculated using the means also. Remember that these are the z-scores for the x values and the y values respectively. So it makes sense then that the linear regression model would also be sensitive to outliers. Or in other words, the linear regression model is not resistant to outliers. So let's take a look at an example in StatCrunch. We have this set of x values and this set of y values. And let's get a look at a scatter plot and what the line of best fit and the plot of the residuals would look like. So we see that we have an R correlation coefficient of 0.967. We have what looks to be a pretty nice linear scatter plot, and the fitted line looks nice as it goes through it. And we appear to have no recognizable pattern when we look at the distribution of the residuals about the line y equals 0. But let's see what happens when we make some changes to this data set by putting some outliers in it. So we're going to click Applets, Regression, Influence. I'm going to generate this from a table, and that is this table that we have here. So I'm going to have x and y as my variables, and I'm going to hit Compute. Now again, we have our really nice line here that we looked at a second ago. And what we're going to do is add some points and see what the effect is. So I'm going to add the point 70, 70. Now that point would be a vertical outlier. It lies above this line. And we noticed that the line made a shift upwards when we did that. Let's add another vertical outlier. 72, 72. Notice that that line shifted up again. Now here's something very useful in StatCrunch that we can do with this particular applet. We can select these dots and it will actually remove them from the green calculation here. So we have this green line here, and we see that we have this check box here, not selected. So I'm plotting, or this line actually is being calculated on both all of the data, that's the red one, and then on the ones that are not selected, so that's the dots that we originally had. And we see the effect that these dots have. They're causing a vertical shift as I select and deselect them. Okay, well, let's do this. Let's add some dots that will look like horizontal outliers. So let's add 11045. Now that had an effect on the slope. Let's deselect that dot. Here we go. There's the red line that represents all of the data, including these ones that are x's, the ones we've added. And the green line is the one that we started with. And we note that as we added in that horizontal outlier, we actually changed the slope of this line. Let's add another one. 11547. It changed the slope some more. Remember that the slope tells us how much y changes according to changes in x. And we see that these horizontal outliers are having an effect on that. Let's deselect that dot now. So we've deselected all of our outliers. Let's put the verticals back in. Slope is not changing there. Now let's put the horizontals back in. The slope is changing quite a bit. Let's add one more. Let's add 120, 42. Again, this has had another profound effect on the slope of this line. Let's select, or let's include all of the horizontal outliers. And now let's exclude them. And now let's include the vertical outliers. So the vertical outliers, again, have had very little effect on the slope, where the horizontal outliers have a profound effect on the slope. Now, what would be the problem with the vertical outliers? Well, when we include the vertical outliers, notice that most of the dots that represent the observed values are below the predicted line. So the prediction value of the model diminishes. Notice when I exclude them, we have a line again that goes through these dots pretty nicely. But the effect of the horizontal outliers changes the predicted relationship between the x and y values altogether. So because of this, the horizontal outliers have their own name. Since horizontal outliers have such a large effect on the slope of the line, they are called influential points.